In this video, we are going to talk about rotations on the XY plane that are not about the origin. So this is a typical example that you might see on your homework where we are asked to rotate triangle ABC 90 degrees around the point 2, 1. You might also see it about the point 2, 1. So folks, instead of rotating about the origin, which I covered in a previous video, we will be rotating around this green point. Now recall, when you see 90 degrees, that is the same as counterclockwise. So positive 90 degrees is going to be counterclockwise. If someone were to ask you to draw a 30-degree angle, you would draw it here. So that's a reminder that positive 30-degree angle is counterclockwise from the x-axis. Another reminder is that if you look at the way the quadrants are labeled, they proceed in a counterclockwise fashion. Okay, now before we get into the specific focus of this video, I'd like to get warmed up by doing some rotations about the origin, because we're going to use some of the similar concepts when we rotate not about the origin. So let's review how we would do this rotation about the origin. So we would start out at -3, -6. That would put us in this location. We would then draw a line to the point of rotation, which in this case is the origin. Counterclockwise would be, if you look at the faces of a clock, which I often encourage my students to do if it helps them, counterclockwise would be to the right. So we're going to go 90 degrees in this direction, and we're going to end up here. Now, because it's a 90-degree rotation, we are going to rotate, or I should say, switch the integers. We're not going to look at the sign until the very end. So this integer 6 is now in the first position, the integer 3 is now in the second position, and now we look at the sign. The rotation of 90 degrees counterclockwise puts us in quadrant 4. If you are in quadrant 4, the x value has to be positive and the y value has to be negative. So that would be our final point. Let's do one more rotation about the origin. Here we're going to do 180 degrees. So let's go to the point 1, 2. We start there. We draw a line to the origin, and because it's 180 degrees, we just keep going right through the origin. So this would, if this was A, this would be A prime. Because it's a 180-degree rotation, we do not switch the position of the integers. We only do that if it's a 90-degree or a 270-degree, because recall, a 270-degree rotation is really a 90-degree rotation in disguise. So here we switch, here we switch, here with 180 degrees we keep it the same. Now let's investigate the sign. If you rotate 180 degrees, you end up in quadrant 3. In quadrant 3, the x value has to be negative and the y value has to be negative. So that would be our final point. Okay, with that brief introduction, let's now move to the specific topic of this video, and we are now going to rotate around the point 2, 1. In other words, we are not going to rotate around the origin. Now, in any of these rotation problems, I encourage you to do these one point at a time. So we are now just going to focus on point A, and then we'll come back and do points B and C later on. Okay, so the first thing we recognize, folks, again, is we are not rotating about the origin. So what I like to do is I take the point about which we are rotating, and I ask myself, if we wanted to go to about the origin, if we wanted to rotate around the origin, what would we have to do to this original point in order to get to the origin? And the answer is, to get from 2 to 0, we would subtract 2. And to get from positive 1 to 0, we would subtract 1. So this is going to be what I am going to apply to all of the points on the triangle to, in effect, create a situation that we are actually rotating about the origin. So let's apply -2, -1 to point A. So here's -4, -1. Those are the original coordinates of point A. We are going to quote unquote apply -2, -1, and we're going to have a new point. I'm going to call that A sub 1, where we just combine these integers and we get -6, -2. Okay, now what we're going to do is we are going to pretend that we are rotating this new point, A sub 1, about the origin. And folks, we know how to do that. So again, we are now going to be rotating around the origin. We are going to start with -6, -2. That is now A sub 1. This homework problem called for a 90 degrees rotation. Recall 90 degrees is the same as counterclockwise. Folks, if you or your students are not sure which way to go, don't be too proud. Put in the faces of the clock, as many as you need to get oriented. Okay? Clockwise would be this way, from 9 to 10 to 12. We want to go counterclockwise. So we will be going left, we will be going to the right, counterclockwise 90 degrees. That would put us in this location, which is now quadrant 4. Okay, so let's look at our points. A sub 1 is -6, -2. We are going to swap the position of the integers because this is a 90-degree rotation. And when we have a 90-degree rotation or a 270, we swap the positions. So the integer 6, again, we ignore the sign. The integer 6 is in the first position, now it's in the second position, and vice versa for the 2. It goes from position number 2 to position number 1. Now let's investigate the signs. We have a new point because we have rotated A sub 1 90 degrees. I'm going to call that A sub 2. So A sub 2, the signs of this point, A sub 2, because we are in the fourth quadrant, the x value has to be positive and the y value has to be negative. Okay, but folks, we are not done yet. We now have A sub 2. Remember when we applied this to the original point to simulate rotation about the origin? We are now going to undo that or reverse it. So this is a reverse of what we applied in blue. Instead of -2, we're going to add 2. Instead of -1, we're going to add 1. So basically, we're going to undo what we did originally. Our final answer is going to be +4, -5, and this is our final point, the third point, otherwise known as A prime. In our next example, we are going to rotate the point B, which has coordinates 3, -5, 270 degrees about the point -1, 1. Now, the first thing I notice about this problem is I'm going to be very careful about these signs. It's very easy to confuse +1 and -1. Next, rather than work with a 270-degree rotation in the positive direction, I'm going to work with a 90-degree rotation in the negative direction. So just to review, if we look at the coordinate axis, if we're going to go ahead and rotate +270, which by convention is counterclockwise, that is the same as rotating 90 degrees in the negative direction. So for me, that's a little bit easier. So I'm going to work with -90. Let's first plot the point B, just to get our bearings as to what we're dealing with. So to plot 3, -5, that would put us in quadrant 4. Okay, the next thing I'm going to do, folks, is I'm going to take this point that they want us to rotate around, right there, -1, +1, and I'm going to change that so that we're doing a rotation about the origin. So I'm going to ask myself, how do I get from the original rotation point, which is -1, 1, again, I'm very careful here to double check that I got the correct signs. So I'm going to ask myself, how do I get from that original rotation point to the origin? Well, I have to do the following. I have to add 1 to the x-coordinate and subtract 1 from the y-coordinate. So I'm going to take this white bracket, these coordinates, and I'm going to apply them to point B, and then that will allow me to simulate a rotation around the origin. So here's the original coordinates of point B. I'm going to apply what's in that white bracket above to point B, and I'm going to get a new point. I'm going to call it B sub 1, and that is going to be 3 plus 1 is 4, and -5 minus 1 is -6. Now, I'm going to now take this through a -90-degree rotation about the origin. Okay, let's do that. Let's go ahead and graph it. 4, -6 puts us here. Again, we're going to call that B1. We're now going to rotate this -90 degrees. So -90 degrees is actually clockwise. And folks, I never hesitate. If for whatever reason I'm not oriented or I'm a little confused, I know -90 degrees is clockwise. So if I want to go clockwise, this is the way the clock moves. It goes from 3 to 6 to 9 o'clock. So I'm going to go 90 degrees clockwise here, and I'm going to call that B sub 2. Folks, I am now in the third quadrant. Recall, when you're dealing with a 90-degree rotation, if these are the original coordinates of B sub 1, 4 is in the first position, I'm going to put that in the second position. The 6 is in the second position, I'm going to put that in the first position. I'm not going to worry about the signs. I'm not even going to look at these signs. When I get to the point after the rotation, I identify what quadrant we are in. We are in quadrant 3. This point, if it's in quadrant 3, has to be negative for an x-coordinate and negative for the y-coordinate. So this is now our second point, B2. However, we are not finished. We now need to reverse what we did to transfer this to an origin problem. We are going to we're going to reverse this bracket here. So we are now going to do -1, +1. We are going to apply the reverse. Basically, we're going to undo what we did here with this blue bracket. We're going to undo that as if we never did it. Our final answer is going to be -7, -3. This is your third point and final point, otherwise known as B prime. In this next example, let's rotate point A, which has the coordinates 2, -2, 180 degrees about the point -1, -1. So if we go ahead and we plot point A, it is going to start out in quadrant number 4. We are now going to convert this rotation, which is about this point, -1, -1. We're going to convert this to a rotation about the origin. So how do we convert -1, -1 to 0, 0? We add 1 to both coordinates. So we're going to take point A with the original coordinates of 2, -2. We are going to apply +1, +1, And that's going to give us a new point, which I'm going to call a sub 1, which is 3 comma negative 1. Okay, so let's now go ahead and plot this new point and consider rotating it 180 degrees about the origin. We are going to start out, a sub 1 is going to be in quadrant 4. We are now going to rotate about the origin. We're going to draw a line from a sub 1 to the point of rotation, and because it's 180 degrees, we're just going to keep going. This is going to be my a sub 2. Now, when we do a 180 degree rotation, we do not flip the positions of the integers. So because it's 180 degrees, the original first position stays in the first position, and the same with the original integer in the second position remains in the second position. I don't even consider the signs. I don't even look at them. I look at them at the end, after I've done my rotation of 180 degrees. I ask myself, where is the point after the rotation? Which quadrant is it in? A sub 2 is in none other than quadrant 2. In quadrant 2, the x value has to be negative and the y value has to be positive. Otherwise, it wouldn't be in quadrant 2. Okay, so these are the coordinates of our a sub 2. Now, folks, we are going to reverse what we did originally. Here we applied positive 1, positive 1. We're going to do the opposite. We are going to apply negative 1, negative 1. And that is going to give us a final coordinate. We call that a sub 3, or a prime, of negative 4, 0.